So today I'm going to be talking about density. That will be today's topic. So density is the degree of compactness of an object. So the degree of compactness of a object. Now, what does this mean? So in simpler terms, it just means how close the molecules of a substance are. So you would say that iron is more dense than feathers, same as you would say gold is more dense than wood. So now I'm going to show you how to visualize density. But first, let me just write iron more dense. Feathers. And in the same context, gold is more dense than wood. So now I'm going to show you a way to visualize density. So if I have a little square over here, not the best, but, and the molecules in this like square over here, they're very, very close together, as you can see. So this box would be more dense than, per se, this box, which has its molecules more spread apart. So now, what would this visualize? So the molecules in this box over here, they're very close together. So this would visualize something called a solid. This one, they're far away, but they're not crazy far away. So this would probably show a liquid. Okay, so now, basically, density can be represented as a formula. So, density, which is denoted as P rather than D, is equal to mass over volume. But before I get into this equation over here, I need to talk about one thing, because many people get this confused. So, what is the difference between mass and weight? So mass is basically how many matter is in an object. So if it has 5 molecules, that's the mass. However, weight, on the other hand, it's basically the mass of an object into the gravitational pull. So on Earth, it would be 9.8. So the mass of an object would remain the same wherever it is, on Earth or on the moon. However, the weight of the object would vary based on the gravitational field. So now let's go back to the equation over here. So P is equal to mv. So m over here, like I just explained, is mass. How much matter is inside an object. So now for volume, there are 2 ways that volume is denoted. So first, for a solid, so this is for a solid, there are 2 ways. For the more bigger solids, meters cubed, and for the smaller solids, the ones that don't weigh as much, centimeter cubed. Now, same thing for liquid. Now the same thing happens for liquids. Milliliter. Now notice how I didn't put a cube. Milliliter already measures how much is inside the cup or container, so I don't have to put cube. So, and also we have liter. But now there's one thing. Now for these 2 bigger ones, mass would not be measured in grams. It would be measured in kilograms for these 2. However, for centimeter and milliliter, the smaller ones, it would be measured in grams. So now let's do some practice problems. So now let's do some practice problems. So I have 6 questions here that we're going to do together. So let's start with the first one. P is so basically for these two questions, we're gonna like find the density of these particular substances. So for the first one, let's do it over here since we have more space. So P is equal to 45 grams over 15 centimeter cubed. So basically we need to find the density. So we know that 15 into times 3 is 45. So we can divide both sides by, we can divide the numerator and the denominator by 15. So that leaves us with 1. And this leaves us with 3. So the density of this particular substance is going to be equal to 3 grams per centimeter cubed. Okay, so now the next question, question 2. Let's do it over here. Okay, so we have density, which you want to find, is equal to 60 grams over 30 centimeters cubed. And right now these numbers are not that hard, they go into one another, but once you get into like, once you find some harder questions, they might come up as decimals. So nonetheless, let's do this. So we can remove the zeros from both sides. So basically we just divided both sides by 10. So now 6 over 3. So now 3 into 2 is 6, so we can divide both sides by 3. So here we have 1, and 6 turns into a 2. So for this substance, P is equal to 2 grams over centimeter cubed. So now, the third question, it says, which of these two substances are heavier? So this should be pretty straightforward. Since from what we did, this has a greater mass. Since 60 grams is greater than 45 grams, it's pretty safe to say that substance number 2 over here has a greater mass. So for this one, we're gonna put substance 2. But now the fourth question, which is more dense? So just because this has a greater mass, it doesn't mean it's more dense than substance 1 over here. We have to look at the mass, obviously, but we also have to look at its volume. And as we solved over here, substance 1 has a density of 3 grams per centimeter cubes, while the substance number 2 only has 2 grams per centimeter cubes. So many times people are tempted to say, well, it's had this substance number 2 has a greater mass, so it would probably have a greater density. But over here, clearly that's not the case. So we're comparing substance 1. Yeah, we're comparing substance 1 and substance 2. So which one is greater? So over here, this one has 3 grams per centimeter cubed, and this one has 2 grams per centimeter cubed. So substance 1 is more dense. So now, question number 5. Now this one is a little bit tricky, but still doable. So question number 5, it says it's 45 grams per centimeter cubed. That's the density. It has given us the density. But here's the thing. We don't know the mass. So for this question, it's asking us what is the mass. So let's see. We can find out the mass. To find out the mass, we have to isolate it from the rest of the equation. So we will do cross multiplication here. So we have 45 grams centimeter cubed. So now we're going to multiply both sides by 9 centimeter cubed. So centimeter cross out, cancel out, 9 and 9 cancel out over here. So now on this side, we have centimeter cancel out. So what is 45 times 9? 45 times 9 is 40. So the mass of this is 405 grams. Yeah, that is not 405 grams. Okay, So that was still sort of simple. So now let's do the 6th question here. So kind of like the other question, we have the density, but we need to, but over here, rather than finding out the mass, we need to find the volume. So let's do it. But first, to make it a lot easier for ourselves, let's flip both of the equations. So the denominator is not the numerator. So now we have all right, so now we're gonna once again cross multiply. As you know, we did it here, so I'm just gonna go straight to it. So V is equal to cm cubed over 45g into 3g. I'm running out of space, but that's fine. So g cancel out, 1/15. So the volume of this is 1/15 centimeter cubed. Okay, so now I have a little experiment. So this doesn't really need much. You just need a mug, a bucket, and some water inside of it. And basically this is just gonna prove that air is less dense than water. So basically take the empty mug and disperse it inside the water. So maybe you can see that this is the air. It's inside the bucket. It's not letting the water, which is more down here, to rise. So how do I know that the air is over there? Well, those are all the air bubbles that were just released. So that proves, see, look, there's still some air left over here. So it just released. So that just proves that water is more dense than air. And this is a really easy experiment that you can do on your own. So yeah, that's the video. If you did enjoy, please do like and subscribe. This was my first video and I did try my hardest. So yeah, thanks for watching.